much for attending, gentlemen, and everybody else watching along later on. We've got Adam here, who's our expert on UPSs from Upsonic. He's got long experience in the industry and lots of good stories to tell you, I'm sure, so hopefully we'll learn a lot with it. But I want to start by just saying, if you're not considering UPS as an essential part of so many different systems that we already sell or supply, then you're doing yourself out of sales and understanding what customers are trying to do. NVRs go dead when the power goes down. You know, medical fridges, vaccine fridges go dead when the power goes down. If you're in the middle of surgery, you know, and somebody's got a power tool to a very important part of you, that power goes down. You want to make sure that comes straight back up or instantaneously ready over to the next one. Yeah, heaven forbid if the internet goes out as well. There's UPSs in all of those environments and situations. So hopefully it's something you start thinking about a lot more, and we can use Adam's skills to design the bigger and better systems for us to look at. So thanks, Adam. I'll hand over.
Thanks for that. So a little bit about me quickly. I'm sales manager for Upsonic. I'm a Sparky by trade. And unusually for a Sparky, I've done a lot of work on UPS. I've been off the tools for over 15 years doing sales, but most Sparkies don't get a lot of exposure to UPS. You know, a tiny little subject within their classroom study. I was working on UPS systems right back as an apprentice, and I've been doing it for over 20 years. So that's a little bit about me. What we're going to cover today. Different UPS technologies and their applications, the terminology, importantly for you guys, what to actually ask of your customer, what you need to know to select the right products for them, the sizing considerations, what things are going to change that, and important accessories, which we've got some here as well, and then servicing requirements, again something that gets missed. So quick bit about Upsonic. 100% Australian-owned company. Company's been going for more than 30 years. It's just actually had a management buyout, so the boss and his wife have actually taken over and now own the business. First company to introduce the personal UPS, so our DSV range, which is something you guys stock. And a .app company, so we're really flexible. We've got a couple of full-time service techs. We're able to, be pretty flexible and react to our customers' needs as they come up. Why a UPS? So everyone understands what a UPS is, knows about the battery backup side of things. Just as important as that is power filtering and monitoring that a UPS can provide as well. So anyone not sure what I'm talking about with some AC waveform? Everyone grasp at least the basic concept? So UPSs will protect against all of the examples that are shown here to a lesser or higher extent, depending on the type of technology, which we'll get into in a sec. So important thing to consider, noise, short transients, notches and things like that is actually becoming more and more of an issue with our power supply in Australia. Again, a lot of that comes back to really crappy LED light fittings and things like that. We can rant on about that for hours. Okay, important terminology. Backup time. So we're talking about the time the UPS will run the rated load on batteries when there's no main supply. That's a pretty simple thing. Some people still get confused about. Inverter, you also hear the term rectifier. Actually, sorry, I'll go back. Inverter is the part of the UPS that changes DC to AC. So it creates our nice, smooth AC waveform. Also have the external maintenance bypass switch. So manually operated switch, this is an example here, that allows us to do maintenance or work or even complete removal of the UPS while maintaining supply to the load. So sometimes also called a wraparound switch. When we get to one of the diagrams later on, you'll see why that terminology comes up, because the supply sort of wraps around the UPS as opposed to running through it. Other important consideration is power factor. So we'll cover the really basics of power factor because we can deep dive into that again for hours. So the important stuff that you guys need to understand, UPSs are always rated in kVA, but your customers' loads will probably be given to you in kilowatts. There is a difference, and you just need to understand that there's a difference in the implications it has, so I'll cover that in a second. And then the other one is the rectifier or charger, depending on the UPS model. So your rectifier takes your incoming supply, typically 240 volts AC, changes it to DC, charges the batteries, and then supplies the inverter, depending on the model. Skip straight through this. So with power factor, we're talking about your wattage compared to kVA, or what is just literally volt amps. So when we measure kVA, you can take the K8, it just means 1,000. We are literally going our voltage multiplied by our current. That gives you that rating. It doesn't take into account the effects on the supply from the different types of load. Different types of load perform differently from an electrical point of view, and what we measure power factor with from 1 and then down in decimals from there. So 1 power factor, what that means, it's pretty rare. What it means is that nice smooth AC waveform that you get, the voltage and the current waveform match perfectly. That's a power factor of 1. Depending on the load conditions, you'll actually get small differences in when those two waves peak and the exact shape of that waveform changes. So important, what you really need to know is we talk about apparent power and real power. Your real power is measured in watts, your apparent power in volt amps, and just like the beer in the example, the glass looks full, but what you really get is the beer less the head. That's a really good way to put it. So you just need.
Instructor did it. We had that same slide.
It was probably the same slide. So the important consideration to have is when we talk about smaller UPSs. So we have our standby systems, and we'll get into the detail of that in a minute. Typically, they're a 0.7 power factor unit. So if you've got a 1 kVA UPS, you're going to get 700 watts out of it. When we go to our dual conversion systems, like
you said they were 0.7 power factor.
Yeah. Okay. So you're getting 700 watts from a 1 kVA unit. When we go to the bigger ones and our big hardwired systems, typically we're at 0.9. So 1 kVA UPS will get 900 watts. And one of our other models sits in between, which we'll cover in a second. So that's a really important consideration for you guys when you're sizing the right thing for your customer. 3 main types of UPS. So we have our offline, which I touched on before, DSV, our Orion, and whoever else's similar competing product. We have line interactive, which is sort of the next step up, and then we go to online or dual conversion. So that's important thing as well. Someone might come in and talk about use slightly different terminology. So offline, sometimes you'll get a standby or single conversion UPS they'll ask for. The other type thing will be for an online UPS. We'll talk about dual conversion. I'll explain why we use that terminology in a second. So with our types of UPS, they have different applications, obviously. So our standby UPS are typically smaller and cheaper to build because with the electronics we'll get into in a second, there's just less of them. Typically they will be a smaller unit on a less critical load. If the load is critical, we'd definitely steer towards the dual conversion units. And then once we go to hardwired systems, it's dual conversion all the way. So the other sizing considerations to keep in mind, up to 2 kVA, we're still at a 10 amp plug top. We then step to 3 kVA, which is a 15 amp plug top. Anything bigger than that's hardwired. So it means an electrician to install it and all of those things. Okay, so our line interactive series covers little ones like the Orion and the DSV. So they're being our standby. And then we have our ESAT and ESART range, which can be either tower or rack mount as well. True versus modified sine wave. This is another important consideration. So we have in blue our nice smooth AC waveform, which is our normal supply. These offline units or standby UPS systems, when they drop onto their batteries, their output looks like the red line. Okay, so that's called a modified sine wave. Most switch mode power supplies, powered equipment, most computers, that sort of thing, they don't care. It just gets gets the voltage. That's enough for it. It's changing it to DC internally anyway. Some systems are sensitive to that. You get some switches, some really high performance stuff, some audio equipment. Actually, a lot with audio equipment. That sort of thing will not like that supply, and it causes lots of other issues. It's one of the reasons why when you go to a bigger unit, that's not the case. So our ESAT range that we talked about in the previous video gives you a pure sine wave output. So it's not perfect, but it's pretty close.
So one of my early instructors on this stuff as well described it as the speed bumps in the car park.
Yes.
Nice round speed bump, your car eats up without too much trouble. Those metal ones they put into car parks and shopping centres, hit one of those too fast and your car starts to have issues. So
yes, it's the same sort of thing. It's again with those standby units, we're talking about the smaller, cheaper end of things. If you're running a PC, a small server, and a switch, that's fine. When you get into more sensitive equipment, then it starts to really matter. Okay, how a UPS works. So the components within a UPS are pretty much, most UPSs have pretty much the same sort of components. So we talk about our line interactive, our standby that we talked about before. So we have a rectifier, an inverter, and a battery. This part of it, this is a filter in this case, or automatic transfer switch when we get to an online unit. Some of those details vary, but one of the reasons why the standby unit is significantly cheaper is this rectifier, all it does is charge the batteries. It doesn't do anything with actually supplying the load. So it's a fairly small component in comparison. The inverter takes the power from the batteries, converts it back to AC and supplies the load. There's also some electronics in there that provide some filtering and try and smooth out the output as best as possible. So our standby UPS just has a little filter in it. It can't do too much more than that. It's a basic in concept. When we get to our line interactive, so with Upsonic, our ESAT or ESAT range, they have this voltage regulating filter. The biggest difference is that rectifier is a little bit bigger. It is able to supply the DC bus within the UPS to some extent. And the advantage of that is it can filter the supply to a higher extent. So with one of these, when the supply gets out of spec to a certain point, it'll switch on to batteries, and that's all it can do. The line interactive unit can do what we call buck and boost. So if you have something where you're getting spikes, it can smooth those out and still actually be running on mains. It's smoothing out those spikes. And also if you get a slight brownout, it can continue to run mostly from the mains and use the battery just to boost that voltage.
So just to clarify, the online UPS, you've got
Yep.
the sine wave coming in. That's doing it from both sides, is that correct? So as soon as it's dropping out, it's kicking in. As soon as it's going too high, it's actually allowing it to kick back in so it can replace that.
Actually a step further than that. So I was actually going to get to that. So with a line interactive or a standby unit, and a normal supply when the mains is running, your supply comes straight through the voltage regulator out to the load. The other stuff isn't doing anything. It's one of the reasons why when supply actually drops with a line interactive or standby, there's a tiny little break until the inverter starts running and the battery supply kicks in. If you connect up a light fitting to it, you can see the light just flicker for a second. Most PCs and things, that's fine. Even a TV, that it won't even flicker on a modern telly. With a dual conversion UPS, it's one of the reasons why we use that dual conversion term, is that it's in a normal operating mode, it's taking the supply coming in from outside It's changing it to DC, charging the batteries and supplying the inverter under normal operating conditions. If you have, you need to manually work on it for bigger units, or if there's a fault, it has a small automatic transfer switch so it can go into internal bypass if it needs to maintain continuity to the load. But under normal running conditions, it is always filtering the supply. So you get a better, more consistent load constantly.
It's also faster too, isn't it?
Yeah, that's the other important thing.
Charged and always full.
Yeah, there's no break. So if the supply fails, the rectifier stops working. The inverter just gets its DC from the batteries instead of the rectifier. There's no break.
Yeah.
It's an instantaneous thing. Okay. So just on that, is there any questions about that? Because I'm sort of going over that pretty quickly, but I don't want to get too deep dive into it. Important accessories. This is something that often gets overlooked, particularly with the customers that have smaller sort of things. So, external maintenance bypass switch. So this is one of our rack mount units. This allows us to take the whole UPS away without disrupting the load. So this will typically be a make before break switch. So as you rotate the switch, it'll be set up where it'll have an alternate input supply. When you switch that across, it connects the other output before it breaks the other input, and that allows the load to see no difference. The UPS is then disconnected from supply and from the output, importantly isolated from the input, so there's no backfeed or anything. The UPS can be worked on, batteries replaced, whatever needs to happen, then put back into service, tested, and then switch back over to being UPS protected again. Important consideration for a lot of customers, even that have relatively small service setups.
I've seen the large box one.
Yep.
Before this rack one, though, does that need to be hardwired?
No, it's just all IEC plugs on the front.
So you like for the
Yep. So yeah, exactly. So with this, you typically put that into the back of the rack because odd-looking things inside the rack, people play with them, which is bad. But yeah, it allows you to have a small pluggable style UPS, but you're still able to do that maintenance or replace it if there's a failure or a problem as well without turning off the supply. You imagine you have a UPS like this and everything's plugged into the back of it. It just has sockets in the back. UPS fails, it might still be supplying the load, but the batteries are dead or whatever. Everything has to be shut down. You're then going to reconfigure and change how everything's plugged in, and then restart all of that equipment just before you can even start to do the maintenance. So this way, rotate the switch, done. Other thing we have is an automatic transfer switch, which is this. This one rack mount obviously, and we can do all different configurations. This is still pluggable as well, just IEC plugs on the back. This allows for automatic switching between different supplies, and you can adjust the parameters and when and why it switches. So if you have a highly critical load, you might supply it from 2 different UPSs. So that's a very common application to have redundancy within the UPS system, and that could be either partial or fully redundant. That way, if the supply if its preferred supply is interrupted, it will automatically switch across to the alternate, and it will do that within 2 cycles, so a 50th of a second. So very, very fast acting switches internally, and yes, so the application for that is it's anything that is really essential to someone's business. Tend to do a lot of that with bigger stuff, but just as an example, Crown Casino, they have one of these and a rack mount 2 kVA UPS on every video recorder that they have within the building. It has an alternate supply, then it has the UPS and one of these. Okay, so applications like that for things that are really critical. The thing we'll talk about again in a sec is software. So our UPSs, to a different extent, depending on the model, have software supplied with them. That allows the customer to do a couple of different things, and depending on the model, they can have add an SNMP card to the product to get the full functionality out of it. It allows them to, I'll get to that in a sec. We'll go into more detail in the software in a second, but they can monitor the UPS, they can monitor their supply, they can look at the UPS's performance, make sure the batteries are working, it'll alarm if there's a problem, all of those sort of things. Yep. Okay, this is the critical stuff for you guys. The questions you need to ask from your customer when they want a UPS. What's the load? That's pretty basic. Okay. Typically, we want to size the UPS at no more than 80% of its load. So, if it's a 1 kVA UPS, and we've got 900 watts in this case, we really don't want to give them anything more than about 750 watts onto the UPS. Allows a little bit of expansion and that sort of thing as well. Do they want a rack or a tower? So, once we get away from the little standby units, all of our UPSs are available in a rack or a tower mount. It's pretty self-explanatory. Is it a single phase or a 3-phase? So once we get to hardwired units, up to sort of 10 kVA, we can do all single phase. 10 kVA and above, we start to talk about a 3-phase UPS, which adds to the complexity and things as well, but important consideration. Is it metro or is it rural? Okay, so that can affect the consistency of the supply that they get. They might have constantly, if they're out in the middle of nowhere, miles away from a transformer, they might have consistently a low voltage. It happens in country areas all the time. That would steer you away from a little standby UPS and onto a dual conversion, depending on the criticality of things as well. That gets into the next point. How critical is the load? Is it running an accounting package at home and they just don't want to lose all of their work? The standby UPS is fine. If they're running if it's a slightly bigger business that's running inventory, their phone systems, everything all through their computer system, and it's a critical failure sort of item, then we'll start to look at an online, a full dual conversion UPS. Does that make sense?
I mean, get people call up and, maybe it's something medical. Maybe just
Yep.
tell them get it done.
Yep, absolutely, yep.
But there aren't any, I've never heard of it, there aren't any standards or particular things that have to conform to, like for medical applications with UPS solutions. I haven't heard of any.
There is, and that gets back to performance and reliability standards. You will find almost all UPS suppliers, even when we supply for a medical application, will explicitly state not for life-saving performance. So typically for anything that's that critical, the actual device itself will have its own battery backup, which is then supplemented by a UPS. So again, we're talking about levels of redundancy.
So home, people that have things at home.
Yep. So you might have a dialysis machine or something like that. Those units will have their own battery backup, but that is a relatively small battery within those sort of things. I've seen the ones I've seen are typically 15 minutes or so. That UPS will then give them that extra continuity to keep things running for a bit longer. And important consideration as well, the standby UPS, no external batteries, it is what it is. When we get to our ESAT range and UMIP, which is this particular one, we can go with external battery packs as well. We can go up to 4 external battery packs on the long runtime version of this. So we can do hours and hours and hours as required, but you're adding to the complexity, weight, all that sort of fun stuff as well. Okay, just a product overview from Upsonic. So we have our Line Interactive series, our standby units that we've talked about here, which is the stuff that you guys stock typically. Our ESAT range, still Line Interactive, a little bit more robust, better performance external battery packs, as we talked about. With these, we go up to 3 kVA. We then step up to our IP range. Now that range starts at 1 kVA for these little ones. We go right up to 10 kVA. From a pluggable point of view, 3 kVA is the maximum on a 15 amp plug. And we do the 16 amp IC versions of those things as well. With the online series, we have our big stuff, which we do in a modular unit. So we do 20 and 50 kVA hot swappable modules, and then up to 30 kVA in a separate unit. And these ones can have internal batteries depending on the actual configuration. So Orion 750, sorry, this is a slide slightly old. It's more like 35,000 of these that we've sold. It's just one of those things. Every Hungry Jack store you go into has one of these running their point of sale equipment, just as an example. The DSV, again, it's well over 46,000, I think it is now, of these sold. Good, solid, robust unit, and they're cheap. So, and it basically hasn't changed for a number of years because it is what it is. Alto series is our ESAT and ESAT range. So the ESAT is a rack tower. You can actually configure, the rack units come with little plastic feet so you can stand it up like a tower if need be. Some people might have a space restriction where they want something that's a little bit narrower, so the rack tower one set up that way can work really well. We do thousands and thousands of these for roller doors, among other things. So any door like that is a entry and egress point with the new building code requirements, it's all going to be UPS protected. Again, so we sell thousands of these for roller doors. This is an example of the software. It allows the customer to monitor their input voltage, the output, the batteries, the load, importantly the temperature. High temperatures kill lead acid batteries, so you make sure it's not getting too hot consistently. And then you can set up here, which is a question we had earlier was about shutdowns. So we can, you can say 10 minutes when the battery gets too low, or however, any combination of the above as well. You can say I want it to shut down after 10 minutes. If the battery drains too quickly, for whatever reason, it can then set up to shut down, so you've got time for that shutdown to be properly done.
With your settings there,
yep.
I understand that setting up and remotely timing, that your meters here, when it comes to diagnostics, and you flick that over to digital, because they're like the analog meters that you'll see there. If you flick that over to digital, would you be able to actually see the notches and say, noise actively as it's incoming into a system?
It won't give you that. It doesn't give you that much detail.
Okay.
So it gives you some basic information and the sort of stuff that the average person can understand as well. Again, it's one of those things. You can put all manner of functionality into it, but a lot of people won't sort of grasp it. So it won't power analyze. It won't. You can't measure harmonics or anything like that with it.
Is the software different on the server rack?
This range, this is pretty much what you get. The software for this range is a little bit different, but it's very much the same thing. You also get a little bit of a graph so you can see, basically you can see how it's working. You could also get how many times you get a mains failure as well, so that can be an important negotiating point when if you're having supply issues. You can actually go back to your UPS log and send that to your supply company and say, last month we had 16 failures, not good enough. And you'd be surprised how often that happens.
Do the domestic ones simply email?
No. So with these ones, with the UMIP and the ESAT range, you can add an SNMP card and you can get that communications. The other one, it's basic communications only.
The beep's pretty loud.
Sorry?
It's pretty loud.
Yeah. It does, and it's annoying.
You hear them call up and they go, oh, hi, in the background, like, UPS. And they go, oh my God, how'd you know?
domestic series ones use their software, analyse the incoming data, and then use that to work out a way of emailing themselves anyway. So if you really want to do it, there are ways around it, but it's a whole another level.
And you can
above.
set up a forward email of that from your service provider as well. Every single time.
You could set the UPS up to send an email to your supply company and say, "Oi, what's going on?" Well,
In a commercial thing, if you've got a commercial business manager for whoever the power company is, yeah, it's entirely possible. So if you really want that communication and things, there are ways around it if you know what you're doing.
Yeah, that tends to be for people who've got more time on their hands.
Like
it
all
was-
software programs.
It would have been easier just to buy the next level up and get the SNMP card. But
Yeah, but
Yeah, that's it.
that's what these guys enjoy.
Yeah, true. Just get an online UPS and you don't need to worry about that. Yeah.
of course, they're still limited by the battery runtime as well. So, and just on that, while I'm mentioning it, with all of the pluggable units, we have a long runtime and a short runtime. So, a partner will end an S or it'll be ST for tower, or R for rack. The S and the L, short runtime, long runtime. Short runtime has a smaller charger, it has space for internal batteries, and you can go up to 2 external battery packs. Long runtime has no internal batteries because it has a bigger charger, and we can go up to 4 external battery packs on those. If you put more than 2 on the short runtime, it'll still work. It'll just take a week to recharge the batteries, literally.
Can you get the, are there any other external battery packs on any other models that you can?
Yes. Well, so not on the domestic or the Orion. Everything else we can do an external battery pack. We can do a custom external battery pack if required. So just as an example, if you had a customer that had a lightly loaded, we actually sell some of these in the chicken coops and people like that to run some of their feeding systems because they get right into the science of feeding and how often they need to be fed and all that sort of stuff. We could put a massive external battery pack on one of those if we needed to. It's doable. So if they needed a day's runtime, we can do that.
So, chickens and stuff.
You'd be surprised that we actually had one that was a 6 kVA hardwiring unit, was 18 months old, and they said, "Oh, it's died. Well, it's still in warranty. Can we?" And they sent it back to us for us to fix it. It had been put in the chicken coop, so it was full of feathers and chook poo and stuff. And they said, "Oh, so when's it going to be fixed under warranty?" We said, "Yeah, no, not happening, fellas." So it's got to be the right thing for the right application. So this is a slightly older slide now. So we're talking about, this is the old version of this, which was called the Cloud series. The new one is UMIP, rest of the part number. Important consideration with this is 0.9 power factor. So the old one was 0.8, so 1 kVA, 800 watts. New one's 0.9, so we get up to 900 watts for a 1 kVA. And obviously it scales.
Is there anything still left of the CS and CRTs and that sort of stuff?
We do. We have a couple of left at the office. I think might be a couple of 2s or a couple of 3s, something like that. There's not much.
What's the replacement for
The
the
UN.
Yeah. So the UMIP, which is this one, the information is in the current price list that you guys have, and as I said, it'll be in that new short form catalogue that we're bringing out. All right. So this is the older slides. All that tech data is available. There's a copy of the catalogue there. There's another copy in John's office upstairs as well, and it's all on the website. So software, it's very similar, but there's a couple of little differences about it, which I don't really need to go into. Something else that you guys just need to be aware of, we have an industrial range. So this is up to 30 kVA, and it's a slightly more robust device. So if you've got a customer that has a particular application, like they want to put it in a shed running a piece of machinery or something like that, then we look at this industrial range. They're used to being, they're designed to be sort of not physically hit harder, but electrically worked harder. Okay, so just bear that in mind. They do cost more, but the difference is about 30%. 1 kVA. I think it's 1. No, this slide only shows to 10. I think the smallest one's actually 6. I'm sorry. There's 6 in a single phase. So that's hardwired.
Single phase as well.
Yes, so 6, 10 single phase, 10 3 phase, 20 and 30. And if you look, the picture's a little bit dull, but these also have space for internal batteries. So that frame size is the same whether it's a 10, 20 or 30 kVA 3 phase. They just have varying degrees of space in the bottom for some internal batteries. With the others, the batteries are all external.
So I had a customer inquire once on a very interesting subject. They were powering up a horticultural unit in the backyard.
Yep.
And they wanted to know if they could series timing on it. So they could just make timing series for the whole horticultural. We want it to run for 7 hours at this time from here to here. And
Yep.
stop and do that. And they
Yep.
wanted to know if there was a safe way or a good way of having the UPS on that without the UPS or anything happening with the whole powering on, powering off all the time.
Full dual conversion UPS will be fine with it. So the UPS will just, if the load goes down to basically to nothing, the UPS will still sit there. It's running, it's still consuming its own power because it's still running itself. The inverter's still clocked. Yeah, and it's ripple charging the batteries, or trickle charging, I should say. So all of that stuff is happening, and as soon as the load comes back on, it's fine. As long as the inrush current is taken into account, if there's pumps or something starting, it's an important consideration. If that's met for their tomatoes or whatever they're growing, that's fine. Yeah. All right, just quickly with our modular unit. Again, not something you guys will come across very much. If you put me onto a project that has this, you'll get a really nice lunch out of it. You guys just need to understand that we have the product available. We can go up to 900 kVA by paralleling multiples of these. The modular units we can do 50, depending on the size, either 50 or 20 kVA modules. And internally, we can set these up to be set up for redundancy. So each row of fans you can see there is one 20 kVA module. They're hot swappable. The shared piece of equipment at the top is the smarts screen, which has got the ATS in it. We can hot swap those modules, and if you have a customer that, just as an example, has a 30 kVA load, they need 2 power modules to supply that load. You can put a third in and set that for redundancy. So every week the UPS switches which module is supplying the load to make sure everything gets even wear and tear. And if one of those units fails, or just as importantly, you need to do maintenance on it, that can be racked out. The load doesn't see anything. That work can be done. A failed module can be replaced, plug straight back in, and the operation doesn't miss a beat. Just a couple of photos of some units in the wild. As someone mentioned before about wall-mounted external maintenance bypass switch. Okay, so for the bigger units, that's what they look like. It's just that enclosure just gets bigger or smaller depending on the size of the unit. An important consideration that you can't see in that photo is that all of these, when you get to a 3-phase, they all have an interlock button as well, because input and output of a UPS can be out of phase with each other. And if you just operate the switch without the UPS being in static bypass, you can blow the whole thing up. So before you can rotate the switch, you must press a button, and the button tells the UPS to match the input and the output up together. So everything's happy before you can rotate the switch. We actually had an electrician that didn't know what they were looking at. We set one of these out the other day, and he said, "Well, why can't I turn the switch?" And he forced it and snapped the switch. So, well, it's got a button. Just press the button. If you don't know what it's for, give us a call. Even though yeah, and there was a whole chart and a drawing of how it works and everything. Again, as I said, a lot of Sparkies don't get any experience with this. You know,
It's three-phase stuff as well. It's industrial. It's not necessarily just single-phase.
Exactly, and
even then, they're 3-phase trained and everything else, but unless you've done a lot with UPSs, what's an interlock? How does that work?
and why is it there? All of those sort of things. And to be fair, most Sparkies, when I went through trade school, I think we covered it for 2 classes. Out of your 3 years of study and 3 years of training on another year of study. So This is just a graphic example of what the maintenance bypass switch looks like. So there's two switches connected together. Instead of supply running through the UPS and out to the load, the UPS is disconnected and the supply runs through there, and that switching is done so the load is not interrupted at all. Thanks for your time. Any other questions, queries, quarrels?
I've got two.
Sure.
Lithium ion.
Yes.
Is that coming? Is that even being looked at? I mean,
Yeah.
I know SLA is so cheap, right? But
Yeah.
it's
It's a slightly complicated answer to that. The short version, yes, it's being looked at. I quoted one just recently. It's horrendously expensive. So the only time it's worth it at the moment, you would even consider it, is really high temp applications. So typically lead acid battery design temperature is 25 degrees ambient. If you for every 10 degrees you go above that, you half the battery life. And that's actually a pretty big difference. This particular application, it was still cheaper for them to change the batteries every 2 years for the life of the UPS than go with the lithium batteries. On top of that, no one that does a UPS, that, at least that I'm aware of, has a charger built in that is designed to charge a lithium battery properly. So when we're talking about batteries of this, we're talking about multiple batteries in series. So even one of these battery, our DC bus voltage is 36 on the small ones, up to 48 for the bigger ones. So multiple batteries in series. When we talk about, and some DC bus voltages go up into the hundreds of amps, hundreds of volts, with multiple batteries in series. Really big stuff, we actually tend to drop back to 48, but that's a whole another long conversation. The point is that you've got multiple cells within a battery string like that. Lithium batteries need to be balance charged, and that becomes a whole complicated thing that the UPSs aren't designed to handle.
Yeah. Well, I mean, we actually sell. We do sell some lithium
Yep.
ions, and they offer the BMP built inside. The chargers and regulars and everything like that. Okay, so that's still tricky.
You've also got to consider when you're looking at not just the maintenance bypass switches and so on for it, but also the circuit design when you're trying to do transfer between the inverters and back to the step-ups on the other side, and how all that goes when you start adding a balance charge circuit into it, and how all that transfers properly and does its thing. For the value in the small systems, it's not there. The lithium batteries, to fill one of those ones would cost more than the unit itself as well. The idea of having a really miniature UPS, like something
the size is the only thing
that can do the same sort of performance as these, but the cost of it would be probably 3 or 4
The-
times.
The only time I've actually seen a lithium installation was a rare one for in telecommunications. So it's where that 48 volts comes from. A lot of telecommunication stuff runs on 48 volt DC. So this it wasn't a full UPS, it was a battery backed up rectifier. So it was taking 415 in, converting it to 48 volt DC with a battery backup hanging off the side of it. So the actual load output was in DC. So that's the only time I've ever seen it done, because complexity was far lower, but it was still very expensive. That was only done because it was an environment it was a big shed that got hot.
Yeah.
That was the only reason.
And what was the largest Upsonic installation out there?
Pretty sure the largest Upsonic installation's 400 kVA, but don't quote me directly on that. But there's a few larger ones. Most of what we do is the smaller ones, but we can do the biggest one. Biggest installation that I've worked on is 3.5 MVA for HP's data center in Tellyho Business Park. So that is, and that was 3N plus 1. So it's triple redundant, and the battery. So each UPS set, because it was multiple UPSs in parallel, had a rack of batteries bigger than this wall. And there's 3 of those. They were also all bus tied together. So if you had multiple UPSs fail, the other ones could actually have all of their batteries all connected back to one UPS. That could all be done separately, and it could also all be done automatically.
How long would it run for?
At full load, it was about 25, 30 minutes, something like that.
That's incredible.
And that was just to cover them in case the generators didn't start and sync properly. Because the generators should theoretically be running and synced in 30 seconds.
Yeah. I know I had some guys, the hospitals, come in and they had, this summer they had failure.
Yep.
Generators didn't kick in. Yeah. And,
Happens all the
they were
time.
out of power for a while.
So that's a
And
real
they test these like all the time.
it's a really common thing. The hospitals are actually, so I used to do a lot of work in some of the big hospitals around Melbourne, and they're supposed to test all of that gear every 6 months.
Yeah.
It's very hard to test. You can test the generator, have the generator start.
But it doesn't have the full load.
The transfer switch is the hard part to test because no one wants to do the full black test.
Yeah.
The only hospital that I know of that does it all the time, every 6 months, is Monash Medical Centre, because they used to have some of our techs go out on site and be ready just in case. They would have a plan with everybody, so no surgeries or anything going on. Their maintenance manager would walk out to the main switchboard, grab the main switch and go clack. Black test the whole site. All right, and that's... Yeah.
I'm pretty sure they weren't doing it. They were doing
No.
the soft test. Yeah. And
And
in the real world.
that only tells you so much.
That's the Monash Medical Centre was the one that I did power engineering at Monash Uni.
Yep.
And the lecturers they had there always held them up as the standards for it. It's just they're that confident they know it's going to work, and they're sort of talking about how well the system went together.
Yep.
So
Well,
it's an amazing thing.
Yeah, a couple of the big UPSs in there, I've worked on the projects to supply them and things. Yeah, so they've got a couple of new ones, but their main system is two 200s in a N+1 configuration, so twice as much UPS as what they need.
In a more sort of general sense, the smaller end of the scale, if you think about a lot of the product ranges that we sell, the big one a few years ago was projectors. Projectors in a home theatre system. The life on a projector lamp would go down by 25 to 50% depending on the projector if the projector was hot to cold straight away, because the heat wasn't dissipating and wasn't shut down properly, so the projector lamp over a few times it was happening would fail. And so you're out $300, $500, $1,000 for the lamp depending on what it was. So putting a small UPS to give you time to shut the projector down in your home theatre would save you hundreds and hundreds of dollars. In a home theatre amplifier, AV receiver, stereo amplifier system, having filtered power for it makes a huge difference.
It's over the years, actually, we used to sell stuff to some of the big picture people places.
Yeah.
Particularly some of the growth suburbs out southeastern side of Melbourne. Some of those guys had, particularly as the suburbs were developing, they would have power issues. And you get guys who are right at the end of the street, away from the transformer, and their main supply could be 200 volts. So you get someone who's an audiophile but lives in that environment, they needed a UPS. So that was a reasonably common sort of thing. I've done stuff for presentation equipment, things like that. So Telstra, for example, in town has a big lecture theatre where they do all their presentations at their head office in Russell Street, or their big office in Russell Street. And within the lectern with all of that gear, UPS there to protect all of that stuff as well, because they were having, they weren't worried about power failure because all the other lights and things are going to go out as well. They were just worried about power filtering to make sure they didn't get any interference over things.
On the note of power filtering,
Yep.
would you be actually looking at making a small, like just a smaller standalone thing, not as a UPS?
Just as a filter. Yeah. We can, it actually used to be something that was really common. So if you look at our website, we have filters and surge arresters and all that sort of stuff on there. Yeah, power conditioner is the term used. We don't sell very many of them anymore because of the cost of them compared to a UPS. Everyone just gets a UPS. There are some applications where they're good. Again, in some industrial applications where they get really hot and everything and people don't want the maintenance of UPS or the battery issues, power conditioner is still a viable option. So we still sell them, just not as super common.
Okay, so
Yep.
price is higher
It's just because it's just volume. The volume of the UPS keeps the price down. Sorry.
Yeah, I was going to ask, on the ideal sine wave, you mentioned before, I think, that external power supply, like, you've got it rigged up to your UPS, and it's going to be a clean sine wave.
Yep.
It's still going to be there. If I had my power supply rigged up to, say, for instance, just a normal input,
Yep.
is there going to be any difference between having it in a normal input and having it in this UPS? Like, there shouldn't be any effect on the battery at all, right?
No. That depends exactly on which UPS you've got. So if you've got a line interactive UPS, and the main supplier is good, the UPS does nothing. It just keeps the battery charged and it monitors things. So there's a little bit of the electronics are running, and all it's doing is just monitoring that supply. So it's ready to change over if there's a problem. So, and the problem could be a spike, a dip, a small brownout, anything like that. Once it gets out of spec, then the UPS starts to do something. So it's effectively on mains until something happens.
So is there anything that could affect the battery life of the computer anyway?
Sorry, of the...
So is there anything that could affect the battery of like a laptop from a UPS?
From causing problems into the actual load, if things are working properly, no. So what you should get out is a nice clean 240 volt output, regardless of what's happening on the input, as long as the battery doesn't go flat. So if there's a problem, then you can have other issues. But if things are working properly, there should be no effect at all. In fact, when we start talking about getting really deep dive science stuff, we start talking about harmonic distortion and things like that. Early UPSs were terrible, and they would actually be one of the worst things in an installation for harmonics. It's now one of the best things. So harmonic distortion, once we get all the dual conversion units, less than 3%. On really critical applications, can actually be tuned to control exactly which harmonics you're looking at as well if there's other issues. So you can actually use a UPS to filter harmonic distortion from a bad load back to the mains as well. So as we start talking about power factor and things like that, we talk about billing. We mentioned power factor before. In the past, and your standard bill at home is calculated on kVA. Some of the big users now are getting kilowatt bills. So they're getting charged extra for that where their power factor is out. Okay, so becoming a really important thing. And they're also getting billed if they've got if they're generating bad harmonics and things like that. And unfortunately, one of the things
LED lights and things like that that actually
Yes.
help reduce that.
Yeah.
Will start to boost up your
this, we can go into a whole big thing about it, because I actually stepped away from UPS for a number of years and worked in lighting. I'm actually a qualified lighting engineer as well. One of the big problems that we are going to have Western society when we go to all of this stuff is we don't regulate harmonics and EMC well enough. In the old days, you would have think of an office building in the city, and it has 100 2x36 watt fluorescent lights on every level. They have a little capacitor in them to try and balance out their power factor. When they turn on, there's a big inrush. We know how to handle that, so you'd have fluoro start switch mechanisms to handle that inrush. All of those things. That power factor was a known thing. It didn't. They were all typically about 0.8, 0.9 if it had a good capacitor in it, but it was consistent. It didn't matter what manufacturer you got your light fitting from. The quality came in the fittings and all of that sort of stuff. The actual electrical performance was almost all the same.
But now you've got so many different manufacturers.
Exactly. So now, the reason I'm not in lighting anymore, every man his dog who sees this government scheme as a way to make more money, they go and buy a container load of crap from China, stick a shingle up and say, I'm now a lighting company, and they sell junk. And the vast majority of it, a lot of it is junk, not all of it, a lot of it is, and the people that are selling it don't even know why it's junk.
Cheaper electricity bill.
Or care.
No, they don't. Yeah.
power here dramatically.
A dual conversion unit is the only way to go with that, because it's actively doing something all the time, where a line interactive unit is only doing it when things get outside spec.
And how does it show you that? Does it show you that in the software where you can manage it?
The software doesn't get into really deep dive stuff. It gives you the basics. It can tell you frequencies out if your input voltage is dropped or going too high. When you start talking about harmonics and EMC, it won't get into that. You've got to go to get a power analyzing meter and put it on there.
Future where we can see industrial ones perhaps better to do that.
Look,
So there's some more possibilities.
it's probably more likely to come in the future because it's becoming more important. So potentially, whether it'll get down to small pluggable stuff, I'm not sure. In bigger stuff, look, it's certainly a possibility.
I think we should probably close up there.
Yep.
Happy with that?
Yeah, no worries.
Thanks very much, Adam.
Thanks for your time, everyone.